Beginning this video, you would be starting to solve problems on fluid mechanics. So first we would solve problems on which fluid is static, and a very important case where analysis of fluid static becomes very interesting is when you have a U-shaped tube and you pour some liquid into the U-shaped tube. See, this apparatus that I have drawn over here, it's shaped in the form of a U, right? And this U-shaped container can contain some liquid inside it. This U-shaped container can have same cross-section in both the branches. See, a U-shaped tube would have two branches, okay? And both the branches may have same cross-section, like over here. Let's say the cross-section over here is A. The cross-section over here is also A. So this U-shaped container has a constant cross-section. We may also have a U-shaped container where the cross-sections are different. For example, over here, the cross-section over here is, let's say, A1, and cross-section on the right branch is, let's say, A2, and you can see that A2 is greater than A1. Now, when you pour some liquid inside these U-shaped containers, the liquid after some time, once you stop pouring the liquid, would settle inside the container, right? Now, what we do in fluid statics is we analyze what is the difference in the height of the surface of the liquid on both the containers. Let me extend further. Let's say on this U-shaped tube where the cross-section is constant, let's keep things simple. We pour some liquid inside and the liquid has a density of rho. We start pouring in, what would happen? The liquid would start settling inside the container, right? It would start settling from the bottom. Now, slowly, the liquid would be filling up the container and the liquid would start rising in both the branches. I hope you understand. The liquid is poured only through one of the branches, but it would start rising in both the branches. Why? Think about it. Okay? Now let's say you stop pouring. You have stopped pouring and the liquid has settled down in both the branches. So, there would be a surface of the liquid on this branch. There would be a surface of the liquid on this branch. So, what you have to do is you have to analyze what is the difference in the height on both the surfaces. Now, if you pour a single liquid, you can understand from logic that the surface on both the branches would be at the same height. What you have to do is first, you have to prove this mathematically, that the surface of the liquid on both the branches would be along the same horizontal level or they would be at the same height. Okay? Prove this mathematically. Let me write down the question over here. Prove mathematically that the surfaces on both arms would be at same height. Okay, do this first. Of course, things would get complicated if, let's say, we pour a liquid first and then we pour another liquid into this container, okay? Let's say that has a density of rho 2. Then things becomes interesting in the sense that the surface of the liquid on both the arms would not be at the same height. But that problem is coming up a little bit later on. But first of all, you prove this one. While you have a single liquid and it has settled down within the U-shaped tube, you have to prove mathematically that the surface of the liquid on both the arms would be at the same height. Okay? Once you have proved this, you have another question for you. Let's say the liquid has settled down. Then you decide to pour some more of this same liquid. So you take, let's say V. V is the volume of the liquid. Let's say you take some V, additional V volume of liquid. The same liquid which has a density of rho, and you pour into this arm once again. What would happen? This surface would rise, this surface would also rise. You have to find out if V amount of additional volume of liquid is poured, what would be the increase in height on this arm and what would be the increase in height on this arm. So you have to find out the increase in heights in both arms if same liquid of volume V is poured additionally. Okay, I hope you understand why I am saying additional, because initially you had poured some amount of liquid which had settled down. You have proved mathematically that the surface of the liquid on both the arms are at the same level. Then you decide to pour some more amount of liquid which has volume of V, density of rho. Okay, you have poured additional volume V. You have to find out what is the increase in height in both the arms. Try it out. I hope you would be able to solve it. If not, the solution is coming up in the follow-up video. Okay, try it out. Thank you.